I'm going to be talking to you about authentication and authorization in Vue.js based single page applications. If you were expecting another talk, you might be in the wrong room. If you're not a Vue developer, maybe you use Angular or React or Svelte or one of the plethora of single-page application frameworks that are out there, a large chunk of this talk will still be applicable to you because we're talking about OAuth and OpenID Connect, that sort of thing. So do we have anybody that works in the identity space with us in the audience? Yeah? Okay, one. Good. So safe to say everybody else in the room is at least identity curious? Right? Okay, cool. And how many Vue developers do we have actually using Vue in production? Okay, cool. Very cool. You should get something out of this then. At least I hope so. So if you have any questions, please use Slido to queue them up and I will answer them at the end. And if we don't get to your question, don't hesitate to catch me in a hallway and ask me a question. I'm happy to talk about these things. Also at the bottom of every slide, I have a link to a page, the bit.ly link down at the bottom. That will take you to a page where you will find my slide deck, including all the notes that I used to give this presentation, and a GitHub repository with the application that all the sample code was pulled out of. So you can actually run that application on your local machine and see how it works. At a certain point in my presentation, I make a series of claims and give you recommendations. These do not come from me. But instead they come from various organizations focusing on those types of things. So like OWASP, NIST, things like that. You'll find links to all that documentation on that same page. So don't worry about taking pictures of my slides or anything like that. Before I start, I would like to thank the organizers and the volunteers for inviting me to my first ever visit to Serbia. I've been working towards international speaking for the last year, and Armada.js helped me achieve that goal, and I'm very grateful for the opportunity. If you're curious about where I'm from, the US is a very big place with lots of regional subcultures. I typically tell people that I'm from Seattle because that's a very well-known city that most people have an idea of where it's located in the United States. But I actually live about 65 kilometers south of Seattle in a city called Olympia, with roughly the same population as Novi Sad, actually. Olympia proper is about 50,000 people, but Olympia is like 3 cities slammed together, and all 3 cities are about 150,000 people. And yes, this is actually my house where I live with my wife, Julia, my mother-in-law, Diane, and a cat named Jade, and my dog, Louie, who features prominently in my slide deck. I've lived here for about 20 years, but before that, I grew up in a place called Green Forest, Arkansas, which is a small farming community based in the middle of the United States with a population of about 2,000 people. I was actually born, though, in Stockton, California, which is back out on the West Coast, but kind of central valley of California. So I'm fairly well traveled within the borders of my own country, which is very large. But I'm very happy to be visiting a place so far away from my home. So thank you to the organizers for having me, and thank you to all of you to come see my talk. I appreciate you. So just a few more things about me. I realize I'm talking about myself constantly, but just to give you some of my background, I'm a developer advocate engineer at an identity and access management company called Auth0. I run the Seattle Identity and Security Meetup as well as the Auth0 online meetups. The online meetups, you guys can join us if you'd like to. We host them at 12 noon Pacific Standard Time, so that'd probably be very late for you, but we do back them up on video on demand. I like to stream on Twitch, and I'm a member of the Live Coders dev team. And I've been a software developer for about 20 years, mainly focused in web development. And this is me and my dog Louie hanging out in the beautiful Pacific Northwest on the Chinook Pass in the Northern Cascades mountain range. So I asked on Twitter earlier this summer, what are some common reasons to roll your own authentication mechanisms? And I got several responses from people, and all of them, of course, are very wrong. Authentication is deceivingly simple. Let's talk about the problem that we're trying to trying to solve when we talk about identity. The idea is that you have a resource somewhere, and that resource can be a capability like executing some specific process. It could be a bit of sensitive data, or pretty much anything else you can think of when you're using an application. And you have a user somewhere that you would like to access that resource in a secure way, meaning it only allows proper usage of that resource. There's not only authentication aspects of this transaction, but there's also authorization as well. Firstly, the problem space that we're talking about is extremely critical. If something goes wrong, it goes catastrophically wrong. Think 11.4 million euros in the event of a breach. That's a career-ending mistake. And this fact alone makes authentication a topic that requires a lot of attention. And I don't put this slide up here to scare you. It's just more, you need to think about it when you're dealing with this. If you publish a faulty cat picture website, you're not going to get fined 11 million euros. But if you leak someone's information, potentially a GDPR lawsuit will come your way that will cost you quite a bit. So you need to pay special attention when you're talking about these sorts of topics. Next, the resources that we're coming from are complex, and consuming those resources are complex. We exist in a world where everything is programmable. Just about everything has an API exposed. And those resources can be accessed by a large variety of devices, not only your computer, but your phone, your watch, your thermostat. I recently went to a big box store called Home Depot to buy a new refrigerator, and they had several models that had the capability of being able to tweet from the refrigerator. I have no idea why I'd want to be able to do that, but I'm highly suspect of the security of such devices. Finally, the accounts that we use to access these resources exist in an incredibly wide variety of sources. Users can come from businesses through enterprise directories. Users can come from social networks. Almost everybody in this room probably has either a Facebook or Twitter or a LinkedIn account. Is there anybody in the room that doesn't have one of those? Yeah, nobody. At least one of us does. Users can come from an entirely custom solution where independent software vendors or a startup decide to put their users in their own database with their own custom rules, that sort of thing. Now consider the Cartesian product of all the possible devices, resources, and user sources, and you can see why the problem can become complex very, very rapidly. Also consider that the developers implementing these things in an organization are not typically experts in the space. They have little desire to become an expert in identity and security. They're primarily focused on shipping product that solve problems for their users. Identity is an infrastructure concern for them at best. This talk was originally formatted for an hour-long time slot. In an effort to stay within the time allotted to me, I've cut this section from the presentation. It deals with use cases that are that specific standards are intended to solve. While it's nice to know these things, they're not critical for the topic at hand. On the plus side, the link at the bottom of the slides contains the full presentation in my notes. So if you're actually curious about these use cases, you can review those, or just catch me in a hallway and I'll talk you through them. So I'm going to skip over the identity access management use cases. With that said, both OAuth and OpenID Connect use tokens as an artifact. So let's talk about them and add some clarity around what they are for and how they're used, and some guidance about securing them. Access tokens are credentials that can be used with an application to access an API. Access tokens can be an opaque string, a JOT, or a non-JOT token. Its purpose is to inform the API that the bearer of this token has been granted delegated access to an API and request specific actions. It's the second statement there that I made, that access tokens can be an opaque string, JWT, or non-JWT string, is just to show you that you can't rely on being able to read the values within a access token. They're not intended for you to be able to introspect into the token to derive any sort of meaning. The only use for an access token is to send it to an API to authorize a request. As long as the place you're sending that token to understands the token, that's all the OAuth spec says about it. ID tokens are a JWT token that contains identity data. They are consumed by the application and used to get user information like the user's name, email address, and so forth, typically used for UI display. ID tokens conform to an industry standard from the IETF called RFC 7519. These are introspectable tokens, so they're just JSON formatted tokens that you can read values out of and do whatever you like with. The third token type is a special token called a refresh token, which contains information required to obtain a new access token or ID token. Access tokens by nature are short-lived because we want them to expire rapidly in case we leak them somewhere. A person that gains access to that access token, we can take it away from them fairly easily through expiration. Refresh tokens, on the other hand, are used to get a new access token in the event you have an expired one. If you've ever gone through an OAuth flow where you authorize an application to use your profile with like Twitter or something like that, and it asks you for offline access, that's explicitly asking for a refresh token to where they can renew an access token without needing you to be there to click confirm, right? These are typically, yeah, I just said that, offline access. So a token is a very powerful artifact because the bearer of a token can access your secured data. First of all, let's talk about storing tokens in local storage. If you go and search for OAuth or OpenID Connect and how to use them in single-page applications, you'll find a lot of information encouraging you to store those tokens in local storage. And this is actually bad advice. There are a number of places where tokens stored in local storage become exposed to the outside world. JavaScript running on any JavaScript running on the page has access to local storage. So if you have a malicious script or a compromised third-party script on your page, it can read local storage object and steal any of its contents. On the other side of that coin, any script that can access local storage can also push malicious data into local storage, which can potentially make it a somewhat untrustworthy source of information. Imagine you're making UI decisions about granting someone access to the admin portion of your website, but I can just go in and mess with local storage and still view those screens anyway. Finally, all local storage is shared within a domain. So if you have multiple applications running on the same domain using like maybe URL rewriting, you have like example.com/admin, example.com/customers, and those are independent applications. All of those applications can access the same local storage object. They can reach in and read others' tokens and things like that, which is a possible source of really hard to diagnose bugs. From your user's standpoint, they just went to the customer application and it errored on them. But what they're not telling you is they went to 3 other applications before that and had a bizarre token stored in local storage that the customer endpoint didn't understand. The most common reasons we put data into local storage is for session persistence, so that the user still has a token if they leave the application and come back. We don't want to make them re-authenticate all the time, especially if they hit the refresh button in their browser. What we can do instead of putting our tokens in local storage, like what solution can we do to get around that problem? And we want to store our sensitive data in application memory. So basically keeping the token in memory itself, and when the user authenticates, our authorization server sets the set of endpoints for issuing tokens can set a cookie in the browser that represents the user's session to the authorization server itself. This cookie is not sent to the API or anything else. It's just the knowledge of the user's session state with the authorization server. So if we go and do something like refresh our browser and lose all of our state, the application reloads and we don't have our token anymore. But what we can do is use that cookie to check the session with the authorization server itself. And if the user's authorization server session is still valid, then we can actually request a new token silently without having to prompt the user for credentials, because the authorization server still knows about that user and has knowledge of them being logged in. So instead of storing in local storage, you just ask the authorization server, do I still have a valid session? And you don't have to force your user to log in, and your token stays secure in that point. So there are certain flows within OAuth that pass tokens by the URL hash of your URL. And there are some inherent security risks with doing this. The token is vulnerable in a number of places. You have it in the redirect URL because you are redirecting the token to some other URL you're assuming is owned by that application. But if that redirect URI was hijacked, then you could be sending your token somewhere you weren't expecting to be. That's issue one. In addition, it's accessible in the browser history, which is also accessible by any JavaScript running on the page. It's also potentially accessible in the referrer header. So if you're under attack and a malicious page is requested right after your authentication takes place, then the attacker can just look in the referrer header and take your token directly out of that. Finally, the application doesn't really know where the token is coming from. It just sees it in the URL hash and it uses it. So it does not necessarily have a way to verify that it's coming from a trusted source or that it was possibly injected maliciously from somewhere else. Now, the people that actually write authorization servers and write libraries for doing OAuth-based authorization and authentication know about these issues, and they implement authentication actively to work to mitigate the risks of these sorts of things. So the mitigation guidance has been around for about 7-ish years for securing tokens in this way. There are no new vulnerabilities that you need to worry about that have been found recently that get around the mitigation strategies that I just mentioned. But as modern JavaScript and web applications evolve, we reevaluate those and recommend new practices. In a few minutes, I'll show you a great way to avoid all of these potential pitfalls to where you don't have to be worried about the mitigation strategies at all. Okay, so let's take a look at the most common OAuth grant variations for web development. And I'm going to start with the authorization code flow, which is typically the OAuth flow that you would use for traditional server-side rendered applications. And I like starting with this one because it's the most complete example of a flow. It has all of the steps in it. So talking about consecutive flows, it's variations on this play. So first we have a user, and that user opens their browser and they enter a URL into their application. This causes the browser to make a request to our web application, and the application serves up the anonymous version of that page. The user then clicks the login link in the application itself, and the web server responds with a 302 redirect to the authorization server. That redirect URL will look something like this. The interesting bits here are the response type code, or the response type of code. That is what makes this an authorization code flow version of OAuth. The browser then redirects to the authorization server's authorized endpoint, which then prompts the user to log in if they need to, if they haven't already, and or provide consent to the scopes that are requested through OAuth. The user logs in and grants consent. The authorization server then redirects the browser back to the application with an authorization code. The redirect URL looks something like this. The authorization code is passed as a simple query string parameter, but this is not dangerous because you can't do anything with that authorization code directly. You need a couple other bits of information to be able to turn that into an access token. So passing it with the URL is perfectly fine. This causes our browser to make a GET request to our original application, passing the authorization code along with it. The web server then makes a post request to the OAuth token endpoint of our authorization server. In this request is included the authorization code as well as the application's client ID and client secret. So those are the 3 bits of information that are necessary to be able to turn that authorization code into an access token itself. The authorization server verifies that code, the client ID, and the client secret, and if it all checks out, it responds with an ID token, an access token, and optionally a refresh token. Which tokens you get depends on which scopes you request in the initial request out to the authorization server. So if you are only asking for a particular audience and a permission scope, you're only going to get a access token back. If you ask for a profile, you'll also get an ID token back. If you ask for online access, you get all three. Offline access, you get all three. The application can then store those tokens in state local to the web application itself. The application then serves up the authenticated version of the page to the user, passing along a session cookie that maps directly back to the state stored on the server itself. Single page applications work a little differently though. Because single page applications run in the browser themselves, an untrusted client, we can't send the client ID and client secret along. We'd be giving away our client secret. So we have to modify the flow slightly to eliminate that necessity. And this flow is called the implicit flow. And we've been using the implicit flow to authenticate single page applications for about 7 years. So if you've done this before, you're probably very familiar with this one. We still have a user that opens up their browser and enters a URL for our application, which causes the browser to make a GET request to our web server. The web server simply serves up our entire application, which has been compiled into static files, and that application's loaded into the browser and runs there. The web server is kind of out of the picture at that point. The application running in the browser simply makes requests to the API directly. So we're not going full round trips for postbacks anymore, which is kind of the benefit of single page applications. The SPA can make direct requests for data to that API, and the API responds with JSON that the application can consume in the browser to do whatever the functionality is that you're writing. Now when the user clicks that login button, the browser makes a direct request to the authorization server directly. It doesn't have a middleman in the middle to do that communication for it. And this time the URL looks slightly differently. Instead of asking for a response of type code, we actually ask for a response type of token directly. The other values needed here are supplied at compile time and loaded into the browser with the application. So the authorization server will then prompt the user, just as they did before, to log in if they're not already logged in, and to provide consent for the scopes that have been requested. The user logs in and grants consent. The authorization server then redirects the user back to the browser, or back to the application. Except this time the token is returned using the hash fragment of the redirected URL, which our application running in the browser can then read and consume. This is the scenario where I was talking about. It is prone to several vulnerabilities. So now let's take a look at a new flow for single page applications called the Authorization Code Flow for Proof Key for Code Exchange. We call it PIXE for short. This flow is very similar to what mobile developers have been doing for a few years now. We are simply applying the same principles to single page applications. Our application is loaded into the browser just like before with the implicit flow. But before we make a call to our authorization server, we need to generate a couple artifacts client side. The first thing we need to do in our applications is to create a random string called a code verifier. This is a high entropy random string. Next, we're going to compute another random string from the code verifier using a hashing method that gives you something called a code challenge. Now, when we make our request to the authorization server endpoint, we send the code challenge along with it. The URL has switched up a little bit. The response type, we're back to code, but we're also passing along the code challenge value along with the hashing method that we use to generate that code challenge. The authorization server will then prompt the user, just like before, to log in if they need to and give consent. Okay, and once the user has authenticated and provided that consent, the authorization server stores the code challenge and redirects the user back to the application with the authorization code. The code is sent to the browser in the hash fragment, and this is fine because interception of that code is not dangerous in the same way that I described earlier. Once we have that code, we can take both the code and the code verifier and send them to the authorization server's token endpoint. And now that what we can do is we can recalculate the code challenge from that verifier on the authorization server itself. And then we want to make sure the challenges match the one that we sent earlier when we initiated the authentication round trip. If the challenges match, then a token is issued as a JSON object and sent to the application, and it can begin consuming it. Pixie is more in line with the original flow that I talked about, the authorization code flow, and does not expose our token by passing them via URL hash. Having said that, all of these flows are pretty involved. And the good news is that all of them are very well understood and implemented by SDKs. So unless you work in the identity space, you'll probably never actually have to implement these flows. Instead, use an SDK that implements them for you. Just be aware of what flows are appropriate for what use cases. If you're doing traditional server-side rendered applications, authorization code flow. If you're or actually that's what my next slide says, so I'll just show it to you instead of saying it before I continue. Yeah, so use the authorization code flow. If you're building single-page applications, but your authorization server doesn't support Pixie, it's okay to use the implicit flow. Just be aware that there are some concerns that you need to be aware of. If your authorization server does support Pixie, then definitely use the authorization code flow with Pixie. So that brings us to the second half of my talk, which is how to implement a secure Vue.js application, and how do we take a generic authentication specification and weave it into a Vue application. Let's start with a bit of a checklist about what I'm going to be covering. We'll add a global authentication service via dependency injection. We'll restrict client-side routing based on authentication status. We'll then handle authentication events like logout and login. We'll look at conditional template formatting based on authentication status. Then we'll look at consuming consuming the authenticated user's OpenID Connect profile. And then we'll wrap it up with how to send the access token along with any requests that you want to make to your API. So authentication is a cross-cutting concern. Different portions of your application need to interact with it in different ways. Vue.js offers two ways to handle cross-cutting concerns like that. Mixins are a flexible way of sharing functionality across Vue components. You simply create an object that defines the shared methods that you want to be able to use, and then declare them as a mixin as a part of your component definition. But this isn't really what we're looking for when we're wanting to inject a global dependency. Instead, plugins are a much better choice for this particular bit of functionality. You're probably already familiar with using plugins if you've done any Vue development whatsoever. Both Vue Router and Vuex are implemented as plugins to the Vue ecosystem. Here's a common example of adding Axios as a global HTTP request handler, making it available for any component that might need it. Note that the comments show you which file each of these things live in. We start at the top with my plugin definition, where I import the Axios library, and then I export an object that has an install method. And then inside that install method, I can poke around on the Vue's prototype to add any objects I want to make them globally available to all other components. So here I'm adding Axios as a $HTTP variable. Then in the entry point for my Vue application, main.js, I simply just import that plugin, and then I tell Vue to use the plugin. This is a very similar syntax for using Vuex or Router. And then when I'm implementing my component that needs to be able to make an HTTP call, I can simply use the object off the this reference to get some data. Pretty simple. So this makes plugging in our auth service pretty clean. In this example, our main.js imports the plugin and tells Vue to use it, passing along the configuration values that are needed. The configuration values here are the domain of our authorization server, the client ID. I'm not passing a client secret because I'm passing it down to a browser, which is an untrustworthy client. But I can still pass the client ID, which is basically used for identifying the application. That's really all it's used for. And then I'm passing an audience in as well. I could also pass scopes here if I have I'm using global scopes. And then the very last thing is a method allowing me to handle application state that will make more sense when I talk about the other end of that particular method where we're consuming this. So I'll save that for a minute. Okay, so you may be thinking to yourself, hey, wait a minute, where did this authorization service come from? There's a whole bunch of math and fanciness involved that I'm hiding under that create service call. If you recall earlier, I said you didn't need to be too concerned with generating or parsing cryptographic keys, and that's because SDKs can handle that stuff for you. And at a low level in my sample, I'm taking advantage of an SDK that Auth0 released recently, which was designed specifically for single-page applications that wish to use Pixie. The service is simply a thin wrapper over that SDK that makes it behave in a Vue-like fashion. So the underlying SDK is not specific to any one single-page framework. It's appropriate for any single-page framework. It will work in Angular, it will work in React, it will work in Svelte. If you go to the Auth0 website and look for examples in those particular frameworks, you'll see us using this SDK and how to consume them there. My examples are going to be all about Vue, though. So that brings us to another nifty feature of Vue, and that's its reactivity model. We're probably familiar with Vue's reactivity model and a component that's defined kind of like this. We start out defining a data element named foo with a template bound to it and its value bar. When the mounted method executes, it changes the foo value to baz, and Vue's reactivity model will automatically update the template's value to match that value. That reactivity is not limited to UI components, though. We can leverage it anywhere. And the auth service implementation is simply another reactive Vue component that wraps the SDK, exposing a set of reactive properties and methods that we can consume from any component. This particular example handles the complex redirect logic described earlier, then fetches the user's profile and notifies anyone that cares that the user is authenticated. This will come in handy later. There's more to the service than what we see in this particular screenshot, but you can check the full functionality in the source code on your own in the GitHub repository. And with that, we've injected a reactive authentication service packaged up nicely as a Vue plugin. So now that we have a reactive auth service, we can start to leverage it to handle restricting access to our client-side routes in Vue Router. And Vue Router is pretty easy to use, and it's in common practice now. Out of the box, it offers several ways to make decisions about route navigation. In this example, we have two of the most common forms of route guards. At the bottom of the screen, we have a global route guard defined on the router itself that affects all routers or all routes defined in that given route. And in the routes definition itself, we have a per route guard that is applied directly only to that route definition. The function signature for both is exactly the same. You're given the route that we are navigating to, the route that we're navigating from, and a next method we can use to either allow the route navigation or to redirect the user back to some other portion of our application. So with that in mind, it's pretty trivial to implement a guard that takes our auth service into account. This guard will allow navigation if the user is authenticated or redirect them to the authentication server. One thing to note here is that we pass some app state along with the request. That lets our application know where to send the user back to once they've successfully authenticated. This is the flip side of the method that I was talking about earlier. So basically with this implementation, the user clicks the link, whatever place they're trying to go to in your application, they're directed to the authorization server to authenticate, and then they come back to the exact place they were trying to navigate to begin with, instead of being dumped in some random place in your app. So back in our router, we simply apply the guard to any routes we wish to require authentication. In this example, I'm applying it directly to a specific route, but we could use it globally, but we would need to make sure to exclude any public routes for consideration. So if your application is predominantly private routes, but you have like a landing page that needs to be public, you need to select which type of route guard you want to use that's appropriate for your app. And with that, we've restricted our client-side routes based on authentication. With all that done, we actually need to let the user log in and log out of our application. And this is surprisingly simple. With our login service exposed as a global service, we literally just define methods to call the relevant methods in our service. Here, our logout method delegates login to login with redirect method. That directs the browser to the identity provider for authentication. There's an alternative method to do it in a pop-up if you don't want to have to redirect the entire browser. The logout method simply makes a call to the identity provider to end the session, so basically clear that cookie that I was talking about earlier, and routes the user back to the root of our application. With the methods exposed, we simply call them via the click directive in our UI elements. And with that, we've handled authentication events, and we've hit the halfway mark of our checklist. There are times we'd like to show or hide elements in our applications based on the authenticated state of the user. Because the auth service is set up to be reactive and is exposed to all components, conditional formatting is pretty trivial. We can use the if directive to ask the service directly. If the user is not authenticated, show the login button. If the user is authenticated, show the logout button. When the reactive values change, the UI will update accordingly. Note we're also checking with the service to determine if it's in a loading state. There's a brief period when the service calls back to the identity provider to get some details needed to validate tokens. So we want to make sure that the service is ready before we start calling methods into it. There's probably a better way to do that check. I just haven't thought about it deeply enough to make it look nice. So bam, that was the fastest one we've had yet. When the user's logged in, we want to give them some indication that that's the case, that they're logged in. And this is also fairly simple, thanks to the reactivity model. Here we use a computed property to return the user profile if it's available, or the default values if they're not. When the user becomes available, it's swapped in. So we're reaching the finish line here. Good, because I think I just saw my 5-minute mark. If you recall, when we configured the user service, we also supplied an audience value, which could have also specified any OAuth scopes we wanted at that time as well. The net effect of doing that is that we're issued an access token, as I described before. Here is a component that loads its own data when it's mounted. We simply ask the auth service for a token and make the request using an HTTP request service, setting headers appropriately. This might look slightly differently if you're using a Flux-like library like Vuex, but I think you get the idea. One thing to point out here is that notice the service method is called GetToken silently. This is a nice feature of the underlying SDK that I'm using. It will check to see if the tokens we currently have in memory are expired, and if they are, it will silently request new ones from the authorization server, which is very nice. I don't have to worry about managing those tokens and juggling them myself. So, and with that, we've completed our whirlwind tour of securing a Vue.js app with OpenID Connect and OAuth. And I am happy to thank you for your time. And if you'd like to keep up with me, you can find me in these various places. Once again, you can find all the presentation materials at the bit.ly link at the bottom. This is probably the slide you want to take a picture of. Also, there is the source code for the demo app that I created that all of the sample code came out of, so you can run that on your local machine. I have various sets of stickers up here for you guys that are sticker hoarders like me. I want to give a special thanks to my coworker, Kim Maida, who graciously allowed me to borrow some of her theory explanations and diagrams for this presentation. So thank you.
Okay, so we have quite a few questions.
Okay.
Okay, let's start. First, what would you say are the best resources to learn this stuff, apart from talking to you?
Sure. I don't want to sound like I'm hawking my company, but Auth0 has really, really good documentation, and we want developers to understand OAuth and OpenID Connect at a deep level. So we have some great documentation and learning materials available on our website. So I would start at auth0.com/docs and just start reading.
Okay. You stated that a malicious script running on your page could read a token from local storage.
Yes.
Any real-world examples on how that script could get there?
Through an ad network. So if you're serving up Google Ads or something of that nature, or you're relying on third-party NPM modules that you're not validating, scripts can come in that way.
Any thoughts on navigation guards versus middleware?
Not off the top of my head, no. I think route guards are easier to understand in terms of Vue anyway. I would be interested to know what use cases you have that would use middleware over a route guard.
Is there some example Vue app that demonstrates these flows and security best practices?
Yes, you'll find them at the bit.ly link.
Cool. How do you handle testing after implementing root guards and conditional auth status?
That's a good question. The route guards themselves are a fairly pure function. So you should be able to wrap the route guards themselves in unit tests without actually having to hit a authorization server. So the guard that I showed, for example, will redirect to a URL. You just mock out that particular piece of functionality and validate that it goes to the appropriate URL.
Okay. Is Auth0 still using JWT for authentication?
Yes. So most of the major identity as a service providers now have standardized on JWTs for all tokens. So Auth0 is one of them. All of our tokens are JWTs. But you need to keep in mind that you can't rely on OAuth tokens being JWTs. It's not a part of the standard currently, and some services don't use it. One that comes to top of mind for me is Twitch. OAuth tokens that you get from Twitch there's nothing you can do with them but send them back to Twitch. The principal engineer named Vittorio Bertucci at Auth0 is a part of the working group that writes the OAuth specifications. He's advocating an addendum to set the standard for JWT for all tokens, but it hasn't been accepted yet.
Okay, and the last question for today. Is it possible for an app to have two auth flows?
Yes, I'm sure it is, but I would question why you would need to do it. I'd want to give some deep thought into why you're doing that before actually trying to implement it. There might be a better way of going about it.
Okay, so guys who posted this question, feel free to come down and ask Bobby after. Thank you.
All right. Thank you all. And don't forget the stickers. Please come take them.